All right. Hello, Patrick and everybody. My name's Courtney, and here is my Module 3 presentation. So, last module of the semester. So, this is just a funny stats joke that I found. If you want to read it, feel free to pause the video, but I'm going to keep going. So, I'm going to start with talking about dummy coding. Coding, then the one that was incorporated to better analyze the data used was dummy coding. It's important to note that rank was one of the variables used and is considered a categorical variable and not dichotomous or continuous. The best action to take is to recode it. So we have a functional regression model. The data is recoded, so each predictor will be entered into the model as a binary predictor, so either 1 or 0. Since there are 4 levels of rank, we created 3 new variables. Our base level is 1, so all other levels are compared to that. There's rank 1 through 4, with 4 being the highest rank. So their codes are based off of 0 being not admitted and 1 being admitted. So first, I ran a linear regression. So standard linear model is part of the general linear model and is used when the DV or the outcome is continuous. All variables used in the dataset included admissions, GRE, and rank. Admissions is the DV or the outcome variable, which is considered categorical and binary. The predictor variable included GRE, which is a continuous predictor, and rank, which is categorical but not a binary predictor. In total, there are 4 predictors, GRE, and the 3 new rank variables, which were dummy coded. First, looking at the R square number, this means that 11.7% of our variance accounts for admission. All T values for the rank levels are negative, which is not good and suggests that there is multicollinearity. The T value for GRE is high, and that's good because we want a big T and low standard error. The VIF value suggests there's no multicollinearity, and the standard error values are low, which is good. All B values for the rank levels are negative, which is another indicator of multicollinearity. The B value for GRE is positive, yet still very low, which remains a concern. Lastly, the significance for each predictor tells us that all values are significant, so we reject the null for each predictor. While conducting diagnostics, we first look at the histogram. The data is not normally distributed and appears to be positively skewed. And the PP plot tells us that there may be a violation of the normal distribution assumption because the observations do not follow the line of best fit. This supports the idea that linear regression does not work well with categorical predictors, which is why a logistic regression is ran to accommodate these variables. So, logistic regression is part of the generalized linear model and is used when the DV is binary. In our logistic regression, first we'll be acquiring the total log probability. We do this by subtracting the natural log b value from 1. For example, for GRE, we would do 1 minus 0.004 and get 0.996. This is interpreted as for every point increase in GRE score, the odds ratio of being admitted increases by 99.6%. The exponential b is the odds ratio and will tell us if the natural log will increase, which happens when the value is positive, or decrease, which occurs when the value is negative. For each dummy code, it is important to remember what each rank code was coded as. For the first dummy code, rank 1 was 0, 2, and rank 1 was 0, 2 was 1, and 3 and 4 were 0. For every point increase in school ranking, the odds ratio of being admitted increases by 27.8%. Since D1 rank 2 is coded as 1, if your school rank is a 2, then you have a 27.8% chance of being admitted. For D2, 1 and 2 were 0, 3 was 1, and 4 was 0. For every point increase in school ranking, the natural log of the odds of being admitted increases by 48%. Because D2 has rank 3 coded as 1, if your school rank is a 3, you have a 48% chance of being admitted. For D3, 1, 2, and 3 were 0, and 4 was 1. For every point increase in school ranking, the natural log of the odds of being admitted increases by 77.8%. Lastly, because D3 has rank 4 coded as 1, if your school rank is a 4, you have a 77.8% chance of being admitted. Next, looking at the interaction between GRE and each level of rank. When there is an interaction between two predictor variables, it seeks to explain how the effect of a predictor variable may depend upon the value of another predictor variable. Looking at a school with a rank of 2 and GRE, it produces non-significant results, which is understandable because the school has a lower rank, so there is a lower chance of being admitted. A school with a rank of 3 or 4 interacting with GRE shows as significant. This is similar to our previous results because the higher rank of school, the higher probability of being admitted. Therefore, interacting with GRE, if both are higher, then the higher probability you have of being admitted. Sorry. Overall, if you have a higher school ranking, then your chance of being admitted increases. Our data passes the assumption of the DV being measured on a dichotomous scale. It also passes the assumption of one or more independent variables, either continuous or categorical. And lastly, it passes the assumption of independent observations and the DV having mutually exclusive and exhaustive categories. According to Preston Wilson, the logistic regression model is usually formulated mathematically by relating the probability of some event occurring conditionally on a vector of explanatory variables to the vector through the functional form of logistic CDF. This is similar to what we did because we related the probability of being admitted to what rank your school was. So, this is the end. To conclude, an important final note is a statement by Friedman. He expresses that regression models are not a good way of doing empirical work in the social sciences today because the technique depends on knowledge that we do not have. He continues to say that researchers who use the technique are not paying adequate enough attention to the connection between the models and the phenomena they are studying. He concludes this implication by saying that the researchers' conclusions may be valid for the computer codes they've created. However, it is difficult to apply those results to the real world. Thanks for watching.